This video was brought to you by the ILC. Hello again, welcome to episode 35, Finding a Diagonal Asymptote. In this episode we're going to take a rational function that has a diagonal asymptote. I'll show you how to find it, and we're also going to draw it on a graph. Let's go ahead and get started. Our rational function this time is x to the third power plus x to the second power plus x minus 2 divided by x squared plus 2x plus 3. You may remember from our previous episode I said that if the power in the numerator is greater than the power in the denominator, that you might have a diagonal asymptote. We can see that the power in the numerator is third power and the power in the denominator is second power. So this is a possible diagonal asymptote, but I want to clarify a little bit also. The power in the numerator, or Pn, must be exactly 1 higher than the power in the denominator. If it's more than 1 higher, you have some other type of strange asymptote which you're not going to have to worry about in this class. But we can see in ours that the top is third power and the bottom is second power. Therefore, our asymptote will be diagonal. To find out what that asymptote is, we have to use long division. So I'm going to put the numerator inside of a division bar, and I'll also put the denominator outside of the division bar. We've covered long division before, but here's just a little refresher. We're going to divide the first term in the numerator by the first term in the denominator. X third power divided by x second power is simply x. Then we take the x times each of the 3 terms that are in the denominator. X times x squared is x third. X times 2x is 2x squared. X times 3 is 3x. After that, you change all of the signs of the terms you've just gotten. X to the third minus x to the third cancels out. X squared minus 2x squared gives us negative x squared, and x minus 3x gives us minus 2x. Then we bring down the negative 2, put it on the side. Now we will repeat that process with our new leading term. We have negative x squared divided by x squared is simply negative 1. Then we take negative 1 times each term in the denominator. Negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. Negative 1 times 3 is negative 3. Once again, we change all of the signs of the terms we've just gotten. Negative x squared plus x squared cancels out. Negative 2x plus 2x cancels out. Negative 2 plus 3 is simply 1. Our denominator is too high of a power to go into 1, so 1 will be our remainder. But the remainder is not what we are interested in, really. We want this quotient up here, x minus 1. We can now say our diagonal asymptote is y equals x minus 1. Let's also graph that quickly over here on the axis I've drawn. Since negative 1 is the intercept, we're going to start at negative 1 right here. And our slope is the number in front of x. Of course, that's simply 1. So we go right 1 and up 1. Draw another dot, and draw a dashed line through both dots. That's what denotes our diagonal asymptote. Of course, the function cannot cross through the diagonal asymptote. It's just going to run along off to infinity. So for example, if we had a vertical asymptote here, I'm not saying that our function has that one, but just for an example, it would run along the vertical asymptote and turn to run along the diagonal asymptote without crossing through either one of them. Thank you for watching this brief video. We'll see you again next episode.